Yourself 1. Find the mean of the number of sentences found in 30 magazine advertisements as is listed on the left bottom corner of page 310. Use this sample to find another point estimate for mu. And so the first thing I did is I went to my calculator and I typed all those numbers in. And so I can show you that. Stat, enter, and enlist when I typed all the numbers in. So when I go back to the main screen, you just type each number and press enter. Go back to the main screen by hitting second mode, and I won't do this with you. And so now we're going to find the mean. And so we can go stat and then over to calc, and we can do the one variable statistics because we have one list of data. Press enter again. If it's an L1, you press L1, or you can just press enter. If it's in a different list, press second L2 or second L3. So here we have an X bar of 14.76 repeating. So we're going to round out to 14.8, and the standard deviation we're going to use for Try It Yourself 3 is going to be the S sub X, which is going to be 16.53 something something. We're going to round it off to 16.5. So we're going to need that S sub X for later, so we're just going to go ahead and get that now. And so we're going to write down our mean, which is our X bar. That's what we're looking for this one, which we found to be 14.8. And that's 14.8 sentences that we were looking for there. And that's all you really had to do for Try It Yourself number 1. But we also need this other data. And so from what we just found, our F sub X, which is our sigma here that we're going to use for Try It Yourself 3, because they ask you to use the information from Try It Yourself 1, give us 16.5. And from this problem we get there's 30 magazines, so that's going to be n is equal to 30. Okay, so let's take a look at Try It Yourself 3. You want to use the data from Try It Yourself 1 to construct a 95% confidence interval for the mean number of sentences found in all magazine advertisements. So we're using just this sample to say something about the mean. And so to do that, we're going to use our formula X bar minus Z sub C, that's the error part right here, the Z sub Z times sigma divided by the square root of n. I just put it all in at one time. And then less than mu is less than X bar plus Z sub C times standard deviation divided by the square root of n. And so now our X bar we found to be 14.8. Now we need to go find our Z sub C. I'm just going to write it up here after we find it. So we have a 95% confidence interval. So we're going to use our table here. So we're going to a 95% confidence interval on this chart here. This is on your formula card. It's the T chart, the T distribution table 5. So we're going to go to our 95% confidence interval. So we're going to go all the way down to infinity down here at the bottom if it's a large sample, and that's 1.96. So we're going to use 1.96 here as our Z sub C. So it'll be 1.96 times the standard deviation, which is 16.5, divided by the square root of n, which is 30, and then we're going to calculate that, and that's going to be less than mu is less than the mean of 14.8 plus our Z sub C, which is 1.96, times the standard deviation of 16.5 divided by the square root of 30. And so now let's take a look at our calculator. So let's go back here, clear that out. And so we're going to type this formula into our calculator. We're just going to do the 14.8 minus 1.96 times our standard deviation of 16.5 divided by the square root is just second, the x squared, which is kitty corner to your 7 there, and our 30. And that's going to give us 8.895. We're just going to go with one decimal place, so that's just going to be 8.9. So we're going to have 8.9 is less than mu is less than. Now this is a nice thing right here where all you have to do is hit second and then enter, and it'll put in what you just typed in. All we're changing here is we're changing that minus to a plus. So we're just going to arrow back, or if your calculator does it like a regular calculator does, you can just go up and change that minus to plus and press enter, and it'll give you that next number, which is 20.704. We're just going to go with 20.7. So it'll be 20.7. So we are 95% confident that the sentences will be between 8.9 and 20.7. Confident that the sentences will be between 8.9 and 20.7 sentences in a magazine article. Here we're in section 6.1, page 316, Try It Yourself number 6. And
we're going to do a sample. So we want to figure out how many magazines we got to include in the sample if you want to be 95% confident that the sample mean is within 2 sentences of the population mean. And assume the sample standard deviation is about 5.0. So we're going to need our formula. N equals Z sub C times S divided by the error. And to find the error, that's going to be the within thing, and that's going to be squared. So that's the formula that we're going to use. And so the first thing we need to do in all of our information. So first of all, they tell us the sample standard deviation is about 5. So our S is going to be 5.0. And when they say within, that's going to be our error. That's going to be our E. So that's going to be equal to 2. So now we're going to find our Z sub C. So to find that, we need to use our table. And so here our table, we're going to look up 95% confidence interval. So 95% confidence interval, go all the way down to the infinity, is 1.96. So we're going to use our Z sub C as 1.96. So let's plug these numbers in. So we get N is equal to 1.96 times the S, which is 5, or 5.0, divided by the 2 squared. And we're always going to round this up. So let's get to our calculator. And so we're going to do, open parentheses, 1.96 times the 5.0 divided by 2, and then close parentheses, and then we want to square that. And so we're going to press enter there, and we'll end up with 24.01. Now we always need to round this up. And so if we take a look back here, we get 24.01. Even if you got 25, I would still go up to 26. You always have to round up. So we need about 25 in our sample to make sure that our sample is large enough.